Okay, so now we're going to show a horizontal stretching or shrinking. And sometimes these are difficult to see because of the functions that, the common functions that we use. If we were doing trigonometry, we could use some trigonometric functions, and those would be a little bit easier to see. But you probably didn't want me to say the word trigonometry. Okay, so let's say we have a function that looks like this. I won't make it too big here. Let's see. I'm trying to be consistent here. I missed one. Let me take that one out. There. And there. Okay, so let's just say it's going like this. Something like that, okay? And hopefully I have it drawn fairly well. Okay, let's look at the table of values for this function. So it looks like we're at -6, 2. So let's call this f of x. And then it looks like we're at -4, 0, -2, -2, 0, 0, 2, 2, and 4, 0, and 6, -2. Okay? All right, now what we're going to graph is g of x is going to be f of 2x. So what we're going to do is we're going to divide each of the x values by 2. So I'll show you one. And then we're going to have the same output. So I'm going to have -3, -2, -1, 0, 1, 2, and 3. But the outputs are all still going to be this. So -2, I'm sorry, +2, 0, -2, 0, 2, 0, -2. Okay? Now, why are we dividing it by 2? Because watch what happens. If I want to find g of -3, then I'm going to have f of 2 times -3, which is f of -6. But I know f of -6, which comes from right here. I know the output is 2. So that's how I'm getting this ordered pair. Okay? So you can do that for each one of them. Now watch what happens on the graph. So I have -3, 1, 2, 3, 2. And then I have -2, -2, 0. -1, -2, 0, 0, 1, 2, 2, 0, and 3, -2. And so I get this, if I try to draw the curve in, it looks kind of like that. So do you see how it kind of squished in? Okay, we call that then a shrink. A horizontal shrink. I think of it like an accordion. You know, you're pulling the accordion out and you're pushing it in. This time we're pushing the accordion in. All the points just got closer to the y-axis. Okay? All right, we can also have, if we take those same points, the orange one, and we were to write, well, I hate to do it in black, but x, h of x, and then let's make h of x equal to f of 1/2 x. Well, then you're going to divide by 1/2, which means multiplying by 2. So now I'm going to have like -12, forgot all my ordered pairs, -8, -4, 0, 4, 8, and 12, but I'll still have these same outputs. So it was 2, 0, -2, 0, 2, 0, negative 2. Okay, so hopefully I got all those right. All right, now if you graph that, you're going to have to go negative 12, 2. So it's going to be like way out there, probably a little further. Negative 8, 0. Negative 4, 1, 2, 3, 4, 0. Oh, I'm sorry, negative 2. And 0, 0. And then 4, 2. 1, 2, 3, 4, 2. And 8, 0. And then negative 12, negative 2. So you get this curve looking like that. And you can see this is a stretch. So it's like you're pulling the accordion out, okay? You're taking your orange curve that you had up here, f of x, and now you're stretching it out, giving you h of x, okay? This was g of x. Okay, so what's the rule to know? If it's a shrink, so you have, where is it? Oh, I didn't write it anyplace. Okay, so I'll write it. If you have g of x is equal to f of cx, if c is greater than 1, it's going to be a shrink. And you have to divide all the x values by whatever the number is. If c is less than 1, and c is positive, so I have to say c is greater than 0, by the way, both cases, then that's going to be a stretch. So it kind of works the opposite of the vertical ones. If c was bigger than 1, it was a stretch on the vertical, but if it was less than 1, it was a shrink. But now for the horizontal, if c is greater than 1, it's a shrink, and if it's less than 1, it's a stretch. Okay, so hopefully that'll make some sense. You kind of have to let it seep in. And now we have an example here. Now, to do these, they make up some functions sometimes. So here's the function that they give us. They give us a picture. It's not related to an equation or one of our common functions. However, we can make a table of values. So let's make a table of values, x and f of x. So we can say negative 4, 0, negative 2, 4, 0, 0, just going by the ordered pairs they give me, and then 2, negative 2, and 4, 0. Okay, so for g of x, I'm going to try to fit this on here. So g of x is equal to f of 2x. So what we're going to do is we're going to make a table of values. We're going to keep the outputs the same, 0, 4, 0, negative 2, and 0. But now the inputs are all getting divided by 2. So negative 2, negative 1, 0, 1, and 2. Okay, so I'm going to scroll up a little bit to graph this. Okay, negative 2, 0, right there. Negative 1, 4, 1, 2, 3, 4. 0, 0. Now that's this curvy part, kind of an upside down bell there. You got to keep the shape, the integrity of the shape. Don't turn it into like a V. I mean, mine kind of looks like a V, but try to get that curve in there. And then you have, okay, we did 0, 0, 1, negative 2, and 2, 0. That's going to be a V shape because we want to be true to our shape here, okay? So it took all the points and moved them in closer to the y-axis, okay? Now, the next one is, let's see. I want to rewrite that graph that we had. X, f of x. Can't remember the points. Okay, it was negative 4, 0. Okay, it went 0, 4, 0, negative 2. Okay, so hopefully I'm remembering those right. And then this was negative 4, negative 2, 0, 2, 4. Okay, that was the original. You just couldn't see it anymore. And now we're going to do h of x. Oops. H of x is going to equal f of 1/2 x. So we're dividing all the x values by 1/2, or in other words, we're doubling them. The outputs are going to stay the same. So double here, -8, -4, 0, 4, 8, and then the outputs are staying the same. Okay, now we graph those points. So -8, 0, -4, 1, 2, 3, 4, 4, 1, 2, 3, 4, 0, 0. So again, that's going to be the curvy part. Just do your best trying to draw them. And then 4, 1, 2, 3, 4, -2, and 8, 0. And that's going to be the V part. Well, it's supposed to look like a V. Now it just looks like a really thick line. Okay, but that's how you do a horizontal stretch and compression. So up here it was, shrink. So up here it was a shrink, the accordion's going in, and here it's a stretch, like the accordion's going out.